So I'm making this video because there were no parametric equations on paper 1. This is Edexcel paper 1 that was last week. So there's definitely going to be at least one tricky parametric equation question on the exam, probably at the end, probably parametric integration. But there's likely to be two, so you might get an easier question earlier on in the paper. And a classic easy parametric equation question is where they give you x in terms of t, they give you y in terms of t, and then you need to eliminate t. So you need to make it a Cartesian equation, which just means y in terms of x. Okay, so I'm going to show you a couple of examples on how you can do this. The main two types of questions you can get on this are either you just have some algebra here, so powers of t, fractions involving t, or even exponentials or logarithms. I would group those all together. And then the second type, which is a bit trickier, is if you have trig in here, then you need to use trig identities. Okay, so that takes a bit longer. But let's do this question as a warm-up first. Okay, so all we need to do, if it's in terms of algebra, is take one of them, make t the subject, and then sub that into the other. Okay, so I'm going to take this one because it's just easier than this one. Make t the subject, so 2t is x plus 1, t is x plus 1 divided by 2. Now we have t in terms of x, we can eliminate t by subbing in this. So we're going to get y equals 4 lots of x plus 1 divided by 2 minus 7 plus, we've got a fraction over a fraction here. Okay, we can just write that as 3 divided by x plus 1 over 2. Now we're just going to go through and expand, simplify. Okay, so here we have 4, this only times the top of the fraction, 4x plus 4 over 2, take away 7. Here we're doing 3 divided by a fraction, so we're going to flip the bottom and times. So that's going to be 3 times 2, 6 over x plus 1. Simplify any more if possible. Here, these both divide by 2, so we're going to do 2x plus 2, take away 7, plus 6 over x plus 1. Simplify again if possible. 2x minus 5 plus 6 over x plus 1. Okay, so now we've got rid of t. All we're going to do is look back at the question. What are they asking for? We just need to get a whole fraction with an x plus 1 on the bottom. Okay, so we already have that partly here. So we just need to turn this into a fraction over x plus 1, and then we can put the two together. Okay, so if we put 2x minus 5, if we make that out of x plus 1, it's currently over a 1. So we need to times the top and the bottom by x plus 1. Okay, so we need to do 2x minus 5 times by x plus 1 over x plus 1 plus 6 over x plus 1. And then simply expand and simplify 2x squared minus 5x plus 2x minus 5 plus 6. We're putting these together because they have the same denominator. And then group any like terms. So 2x squared minus 3x minus 5 plus 6 is plus 1 over x plus 1. And that's in the form they're asking for. So that's it. Okay, so the method for that is always the same. If it's in terms of algebra, you just need to get t by itself and then sub it into the other. Okay, so let's move on to a trickier type of question here. So you can see these are trickier because we have trig now. Okay, so they're asking for the same thing. They're saying, can you get rid of t and just have y in terms of x? So looking at this, the first thing to compare is we have, in fact, for any trig parametrics question, if you need to get rid of t, you need to think of a trig identity that links the two together. Okay, but first things first, we're going to make the trig part the subject here for both of them. So we're going to do sine t is x minus 3 over 2. And then here we're going to get the cos part by itself. So cos 2t is y minus 4 over 2. Okay, and now we need a trig identity that links the two. So you can see this is cos of 2t, this is sine of t. We can use the double angle formula here. Okay, so we can turn this into sine t. If you remember, you've got the 3 different types of cos 2t. So you've got cos 2t is cos squared t minus sine squared t. You've got that's the same as 2 cos squared t minus 1, and that's the same as 1 minus 2 sine squared t. So hopefully you know this off by heart by now. So then you would just choose the one that works the best for your question. I mean, this is in terms of sine t. So you can see this will be the best one to choose. So we replace this, 1 minus 2 sine squared t is y minus 4 over 2. And sine t is x minus 3 over 2. So we can see if we want to get rid of t, we've got sine squared, we've got sine t here, so we can replace the sine squared by this squared. So if we sub that in, it's 1 minus 2 lots of x minus 3 over 2 squared is y minus 4 over 2. And then, as always, we just expand and simplify. 1 minus 2. Looking at what they want, they've kept the x minus 3 squared here, so we don't want to go through the whole hassle of expanding everything, simplifying, and then we're like, oh, we've got to factorize again. That's a waste of time. So we're just going to keep the top as x minus 3 squared. Square the bottom. Okay, you can see here, just going to cancel that, so it's over 2 equals y minus 4 over 2. Times by 2 here, 2 minus x minus 3 squared is y minus 4, and then just move your 4 over. Y equals 6 minus x minus 3 squared, which is what they're asking for. So then we're done. Okay, so those are the two types of these parametric equations you can get when you need to eliminate t. So if it's algebra, let's go back and look at the algebra question. If it's algebra, you just make t the subject and then sub it into the other. That's the nice kind of question. If you get a trig one, you rearrange them both to make the trig part the subject, and then you think of one of your trig identities that links the two together. And that's it.